Hello and welcome to the second video of 6, talking about elevating electronics. So today we will be looking at, again, the Otis touch tube. Last time we talked about basic principles about how this tube actually runs, and today we will now talk about how you can wire these tubes, first in a bit of a simpler way that isn't correct, and then in the proper way which is correct. Now, the first and simplest way we can wire this thing is actually just using house wiring. I mean, we got 120 volts AC, and it's pretty close to what the normal trigger voltage they use for the actual tubes are, which is 150 volts AC. And even though it uses DC for the anode applied voltage, we can get away with using AC. Now, I don't advise you do it this way, because apart from the fact that these tubes weren't really meant to run on AC, specifically the anode applied voltage is being AC, it'll also provide some interesting things that we'll have to note once we actually get this thing wired up. So actually, to wire this thing, we've got a simple tube base here, which this tube base is wired differently from other tube base. There are a few different types of tube bases that Otis actually uses. This is one of them. This one specifically is for car calls, so in the car operating panel, and this one, which I mounted to this piece of wood, is used for the hall calls. My bad. And they are wired differently, so it's important that before you start wiring one of these things that you know which tube base you have and how you need to connect it. Now, I'm going to assume right now, for the purpose of this video, that you know how to do continuity checking, so that you know which pins are which. So I'm just going to leave it at that and say which parts of the actual tube you need to connect this to. So, first things first. We only need 2 wires here. We are not using ground, even though that would be kind of expected. So first, we need to connect the live wire, the black wire, which is 120 volts AC, to something. And what we are connecting it to, we are going to connect it to the cathode. And the reason we are connecting it to the cathode is because the grounding rod, which we need to be the opposite of what we are using the cathode for, needs to be is black, basically. So the live wire is separated from the grounding rod. If we were to use white, the grounding rod and the cathode would be at the same potential. So that's not what we want. So we are using the black wire for the cathode. And the cathode on this one is this one right here. So as you can see, we have connected it to this pin right here. And because the cathodes are not connected together on this tube base, we need to add a little jumper to the other cathode, which is this one right here. So now we have just jumped across this pin to this pin, so now they are at the same potential, which is 120 volts AC. And now all we need to do is connect our neutral, which is the grounding rod, and we connect it to the anode. And the anodes together are connected together on this one. So we only need 1 wire to go into either this one or this one right up here. The one in the center is for the grid, which we don't need for this purpose. But when we get into crossfiring, we will actually need it. And one quick thing to mention is that sometimes they will actually omit this actual pin here, the one for the grid. And what they'll do instead is they'll just directly connect the grid to the cathode on the back of this tube base. So if you have one of those that has the grid pin omitted, you won't unfortunately be able to use cross-firing. Not that you need to do cross-firing, I mean, very few elevators have it nowadays. So, now that we've gotten this thing all wired, we just need to plug it in. Now, I'm just going to mention right now that these tubes have a special tin coating on the top. It's very thin. It basically helps make the actual glass more conductive, so that when you touch it, it forms a better capacitor, which allows the AC to flow through. But if you keep touching it, you're going to rub it off. So what we can do instead is use the ground here. I know I'm being kind of oxymoronic here. We were not going to use the ground wire, but we are now. Basically, all we need to do is have a grounding rod somewhere, which we can just use a simple screwdriver. And I don't think I have a screwdriver that fits this thing. I'll be right back. Alright, I'm back now. Now I have an actual metal thing that I can use as a grounding rod. Now we don't need to worry about touching this thing until we actually touch it to the tube. So now all we need to do is plug it in, which I will do right now. So now we are plugged in to 120 volts AC. We have the cathode at 120 volts AC relative to the grounding rod, which is basically the white or the green wire in this case. And now, if we take our grounding rod basically and touch it to the tube, it lights up. And it lights up pretty well. But if you notice and you actually listen closely, and I'll just bring it closely here so that you can hear this. You can hear it's kind of buzzing quite a bit. And the reason for that is because we are actually putting way too much voltage across this tube. Now you might be thinking, well, it's meant to run at 150, isn't it? Then how are we putting too much across it? That's because we are missing something. So this tube base right here that is used in the car, it has these big resistors, these 2-watt resistors right on the front here. These are actually the main current limiting resistors. So if we just use a tube like this, which this tube doesn't have those big 2-watt resistors, if we actually measured this, we're putting around, let's say 50 milliamps of power through it, which doesn't sound like a lot, but for these tubes, the maximum current that you can put through this is only 25 milliamps. So we're putting like almost double through it. Now the reason that our tube isn't exploding is because it is AC, and thus it, isn't exactly always 50 milliamps, so we are saved by that. But if we were using DC, the tubes would either burn out, or one of the resistors that are underneath this thing would probably burn and explode. So good thing that's not happening. And you see, it still works, even when I only use my finger, but if I touch both at the same time, strobes, that's very strobes. And you see, it doesn't work that well. So while this is one way that you can get them to work, it's not the intended way on how you actually work them. And so, with that in mind, I will show you now the proper way to actually wire these things.